Welcome everyone to this presentation on Internet protocols in data communication and networks. Internet protocols are the rules and standards that governs data communication over the internet. So they enable communication between devices, ensuring that data packets are sent, received, and correctly. So we need to move on to addressing in TCP IP. So the protocol suite involves 4 different types of addressing. We have physical addresses that uses MAC addresses to identify devices at the data link layer. We have logical addressing. This one uses IP addresses to identify devices at the network layer. Then we have a port addressing. This one uses port numbers to identify processes running on a device. Then specific addressing uses specific addresses to identify specific devices or so here we have physical addresses that we said that this one uses MAC addresses to identify devices at the data link layer. So the physical address is usually included in the frame and is used at the data link layer, right? So MAC is a type of address that is 6 bytes, 48-bit in size, and is imprinted on the network interface card device. On logical addressing, we say that this one uses IP addresses to identify devices at the network layer. So most of the time the data is to pass through different networks. Since the physical addresses are local to the network, there is a possibility that they may be duplicated across multiple networks. Also, the type of physical address being used may change with the type of network encountered. For example, Internet to wireless to fiber optic, hence physical addresses are inadequate for source to destination delivery of data in the network environment, therefore a logical address. Then we have 2 versions of IP address. We have the IP version 4, which is the 32-bit address capable of supporting 2 to the power of 32 nodes. Then we have IP version 6, 128-bit address capable of supporting 2 to the power of 128 nodes. So when I'm saying an IP address is a unique numerical label assigned to each device connected to a computer network that uses the Internet protocol to communicate. So every device that is connected to the Internet has got an IP address, and an IP address is a unique identifier of which device that is connected to the Internet. So when you're talking of an IP of a unique identifier, we can give example for license plate numbers on cars. They are unique. Each car has got its license plate that is unique. We can also talk of a student at a university. Every student is identified by a reg number, which is unique from each other. So a student is identified by a unique identifier called a registration or reg number. So when you're talking of IP addressing, we are saying that every host and router on the internet has an IP address, right, which encodes its network number and host number. The combination is unique. In principle, no 2 machines on the internet have the same IP address. Just like a car, every car has got its license plate number, right? So no 2 cars have the same license plate number. No students have the same registration number. So an IP version 4 address is 32 bits long. They are used in the source address and destination address fields of IP packets. An IP address does not refer to a host, but it refers to a network interface. So IP version 4 uses 32-bit addresses, which means that the address space is 2 to the power of 32, or the number given on the screen, which is more than 4 billion. Then we have 5 classes of IP address. The first class is 1.0.0.0 to 127.255.255.255, and the class A has got 8 network bits, right? and 24 host bits. Then on class B, we have 128.0.0.0 to 191.255.255.255, and this one has got 16 network bits and 16 host bits. Then on class C, we have 192.0.0.0 to 223.255.255.25, right? And this one is got 24 network bits and 8 host bits. Then we can look at the multicast address. This one 224.0.0.0 to 239.255.255.255, and this one is used for multicasting. Then we have class E, that's 240.0.0.0 to 255.255.255.255, which is reserved for future. Then when we're talking of subnetting, a subnet mask is a 32-bit number that determines the scope of a subnet. It is used to divide an IP address into a network address and a host address, right? And we are talking of subnetting, and the subnet is the process now of dividing a large network into smaller subnetworks, right? So to implement subnetting, the router needs a subnet mask that indicates the split between network plus subnet number and host. For example, 255.255.252.0/22 or /22, the /22 indicated that the subnet mask is 22 bits. Right. So to determine how a network assigned can be subnetted, the following must be considered. One, the number of subnet is given by 2 to the power of n, right? The number of subnets is given by 2 to the power of n being the number of ones in the network ID, right? So n is the number of ones in the network. These are borrowed ones in the network ID. The number of hosts per subnet is given by 2 to the power of n being the number of bits on hosts, right? This gives the number of IP addresses per subnet. Shall look at this one. So the number of addressable hosts is given by 2 to the power of n minus 2, and this is because the first address in the net is the network address and the last is the broadcast address. So let's look at this example. The subnet of this address is 255.255.255.192, right? Since we have borrowed 2 bits of the host ID to have 26 ones, right? So if we look at the first octet has 8 ones, the second octet has 8 ones, the third octet has 8 ones, and the last one is 2 ones. And these 2 ones are the ones that we are saying have been borrowed from the host, right? We have borrowed 2 bits of the host ID so that we have 26. If you count the number of ones on the screen, you see that we have 26 ones, right? So the number of subnets that can be created is 2 to the power of n1, and n1 is the number of borrowed bits, borrowed host IDs, right? So we've borrowed 2 ones. If we check on the last octet, you see that we've borrowed 2 ones, right, from the host ID. So we say 2 to the power of 20, we get 4 subnets, right? Then on the number of IP address per subnet, then it becomes 2 to the power of n2, and the n2 that we are saying is the zeros that are left, the number of zeros on our host, right? And we have 6 zeros, right? So then our number became 2 to the power of 6, which is 64 IP address. Then number of addressable hosts becomes 2 to the power of n2 minus 2. So this is 2 to the power of 6 minus 2, which is equals to 62 hosts. We have removed the first address, which is the network address, and then we've also removed the last address, which is the the network address, the broadcast address. So if you look at the N1, this is the borrowed ones, then N2 is the number of host bits that are left in a network address. This is how we calculate the number of subnets. This is how we calculate the number of IP address per subnet and the number of addressable hosts in a network. So in our next lecture, we shall consider this example. We're going to calculate this together in our next lecture. Thank you for listening to this presentation. Comments, questions, I will come in the comment section. And this marks the end of our lecture.